Hello students, welcome to lecture 30. So we are starting the next module, module 4. So our next topic of discussion is DC to DC converters, which are also called choppers. Um, so by the end of this class, you will be able to describe the operation of step-down choppers, which is also called buck converters. Okay. So, uh, so as I said, it is a DC to DC converter. So you have DC voltage, okay? Say it can be from a battery or a rectifier filter. Um, However, the value of these fixed DC voltages may not be, say, useful for the load where you are connecting it. Say, for example, the load may demand a DC value, which can be of, say, 5 volts or plus or minus 15 volts, like what we need for analog signals. The load may demand 3.3 volts or 1.8 volts, like most of the digital circuits require 1.8 volts, so on. So the load may demand different level of DC values. So you need to have a proper or a suitable power converter, wherein which can convert this DC level of one DC power of one level to DC power of another level. Okay, so in such situation, this DC to DC converters come into picture. So today we will be discussing the step down type of DC to DC converter, or called the step down chopper, which is also called as buck converter. So a definition of a chopper can be a device which converts constant DC voltage into variable DC voltage. Okay, so which can be called as a DC to DC converter or a chopper. So if you think of applications, then you can imagine subway cars or trolley buses or battery driven vehicles where these DC to DC can be imagined. Okay, so as you can see here, this is our constant DC supply, right? The DC voltage. So here what you can observe here is the variable DC. So if you have a circuit which can give you this variable DC, then that circuit is nothing but a chopper, right? So based on different operating modes, the chopper can be classified into different categories. So the first category is according to the input or output voltage levels. The chopper circuits can be categorized as a step down chopper or step up chopper. So obviously, as the name indicates, in step down chopper, the output voltage will be less than the input voltage. Okay, and in a step up chopper, obviously the opposite of that, the output voltage will be higher than or greater than the input voltage, or larger than the input voltage, to be more precise. The second category of classification will be according to the direction of the current, the output voltage and the output current. So based on the directions, the classifications of the choppers will be classified as Class A, Class B, Class C, Class D, and Class E. Okay, so the third category is according to the quadrants. So as it is indicated here in the figure, The class A category and class B category falls into one quadrant um, choppers or first quadrant choppers, where the output voltage and current both will be positive. Whereas in two quadrant choppers, as you can observe here in the class C or class D, in class C, the voltage can be positive and current can be positive or negative, as in class C. In class D type, the current can be positive, but the voltage can be positive or negative. That is class D. So these two are two quadrant choppers. Whereas the class E type of chopper is called four quadrant, where the output voltage and current both can be positive or negative. Okay. So um, based on the direction of the current and voltage, the choppers are classified into these five different categories. So today we will be discussing the step down chopper. So as I mentioned earlier, in step down chopper, the output voltage, as it is shown here, if you say the V naught is indicated, which is your output voltage, and if you take Vs as your input voltage, their output voltage will be less than the input voltage. V naught will be less than Vs. And the typical chopper circuit representation is shown with a dotted rectangle as shown here. So basically this is the chopper circuit representation with a dotted line rectangle, wherein it is the thing inside here is a switch, which is made of power semiconductor device, which can be one of these. It can be a SCR, it can be BJT, power MOSFET, IGBT, GTO, MCT, etc. So the power semiconductor device used as operating as a switch in the circuit is nothing but your chopper circuit. So the main principle of this chopper circuit is that in order to get the variable output, what we are trying to do here is we are trying to keep the switch on and off for different time period. Okay, that means you're keeping the switch on and off for different time, or repeatedly you're making this switch on and off. So based on that, the output what you'll be getting will be a variable DC. Okay, so let us understand the step down chopper circuit. So in order to have this step down chopper circuit, first we need a constant DC voltage, the input voltage, which is our Vs here. Okay, and the dotted line here, the dotted rectangle indicates the chopper circuit, wherein it can be made of any of the power semiconductor device. Then you have a inductor, you have a freewheeling diode here, and you have the load. So the power diode operates in a freewheeling mode to provide the path for the current to flow when the chopper is off or the switch is off. The smoothing inductor filters out the ripples in the load current, and here the chopper or the switch is used uh, or to keep it conducting for particular time period, and block it for uh, the time period that is the off condition. So let us observe how it works. Okay, So the circuit can be understood with uh, in two parts of its operation. So in the first part, when the chopper is on, say the switch is on. When the switch is on, as you can observe here, it is indicated with a short circuit when the chopper is on. Here is your DC supply, constant DC supply. When the chopper is on, if you can observe here, the diode will be reverse biased because the potential at this anode terminal of the diode here in the main circuit, it is connected to the negative terminal of the supply. So the diode will be reverse biased. So here is where we are looking for the output V naught. Okay. So when the chopper is on, there is an inductor. Okay. So this is acting as a short circuit. So as you can observe, the output voltage here will be equal to Vs when chopper is on. And also that is the first point what we have to note. When chopper is on, the voltage across these points will be equal to Vs. The constant DC voltage what you have applied. The second point to note here is the inductor which is connected here in series with the load is getting energized when chopper is on. In the second part of the circuit, that is when chopper is off, we know that when it is the switch is off or the chopper is off means it is open circuit. So because of the presence of the inductor, now the energy is released from the inductor. So that will cause the current to flow in this path, causing the diode to be forward biased. So the diode will be conducting. So there is a path for the current to flow in this path. So the output voltage here will be the drop across the diode. So which will be minimum. Okay, it can be 0.3 or 0.7 or depending on the power diode what is used, which will be very minimum, so which is taken as 0 here. So these are the three equations which you have to understand, know to understand the working of the chopper circuit. So when chopper is on or when it is conducting, the output voltage will be equal to Vs. Okay, and the inductor is energized, and when the chopper is off, as we started with the discussion, that the chopper circuit operation is in such a way that you keep this chopper on and off repeatedly, right? That is how we are trying to get the variable DC output at the output terminal. So when the chopper is off, output voltage will be equal to 0. So let us see the same representation in terms of waveforms. So here I've shown here. So this is the T on period. For T on period, when you are keeping the chopper on, when the chopper is on, the output what you are getting will be equal to Vs. So it is indicated here, the output voltage, it is equal to Vs for the time duration T on till the chopper is kept on. Okay. So when the chopper is made off, say for time period T off, then you have no output voltage. So output voltage will be equal to 0. So that is what is indicated here. Again, if this is repeated in a particular frequency, then for the next T on period, the output voltage will be equal to Vs, and in the next T off period, output will be equal to 0. Okay. If you observe the output current here, I naught, so because of the inductor present in the circuit, the current is raising in the T on time duration, and in the T off duration, the current will be discharged from the inductor, so the current is falling. In the next T on period, again current will be raising in the circuit. So the current waveform is depicted or shown here. So in the textbook, this is the waveform what is visible there. The terms used are E naught, to represent the output voltage. EDC is your input voltage, that is fixed DC input, and capital E naught is the average DC output. Okay, so T on is the time duration as it is indicated where the chopper is on. T off is the time duration when the chopper is off, and this total T time period, which is equal to T on plus T off, is the total time period which is called chopping period. So this capital T is called chopping period. So the current waveform is indicated here. So it will be raising during the T on time period, and it will be falling or decreasing during the T off time period, and it repeats. So this is what is indicated in the textbook. So the terms what I have used here is V naught and Vs. V naught for output voltage and Vs for input. That's the only difference. So in order to calculate the average output voltage, we know that to calculate the average output voltage V naught, okay, what will take the area under this curve, right? So it will be Vs into for time duration T on. Vs into T on, that is amplitude and the width, that will give the total area of this pulse. Okay, so Vs into T on plus 0 into T off whole divided by the total time period T. Yeah, so V naught will be equal, the average output voltage will be equal to Vs into T on by T, where T on by T, we know that it is the duty cycle, right? Where T is the total time period, T on is the time duration for which the chopper is kept on. So it's a duty cycle where we can represent it as D. T on by T can be represented as D, which means that we can rewrite it as V naught, the average output voltage, it is given as Vs into D. Okay. So from this relation, we know, from this waveform also we know that T on time period will be always less than T, the total time period. Okay. So which means T on by T will be less than 1. So obviously, according to this relation, the output voltage will be obviously less than the input voltage. Hence, this circuit is called step-down chopper. So that is about step-down chopper and its operation. I hope it is clear. You have to note down the operation in the two condition when chopper is on and chopper is off. You have to represent the working of the circuit with the waveform and give the average output voltage. So based on this, again, you can give average value of the load current as well. So from this, we know we can write the average value of the load current as I naught, which will be equal to V naught by R, right? So this duty cycle, it can be also represented as alpha. So textbook uses alpha there in place of D. So we can also write the average output voltage as Vs into alpha. So where alpha is nothing but the duty cycle, the ratio T on by T. So that's all about step down chopper.